Welcome back to the GCSEMathsPro YouTube channel. So today we are going through the paper 2 calculator paper from June 2023, obviously Edexcel. If you want to go through this paper with me, then just make sure that you do bring along your calculator as well, because you obviously will be needing that for all of these. So let's just get going. If you have any questions, feel free to leave them in the chat. And we're just going to keep going. So question 1, we've got a really nice one to start with. Work out the value of 25 minus root 43.87 over 6.21 squared. Sorry, 6 plus 2.1 squared. Write all the figures on your calculator display. This is really nice. You literally just have to type it in and then copy everything down. So, grabbing our calculator, let's type this in. 25, let's get our fraction as well, shall we? 25 minus root 43.87. Obviously make sure you type it in correctly, otherwise that will be a waste of a mark. 6 plus 2.1 squared equals, and then you can see we've got this whole number here. So we're going to write down every single digit in the answer box. So we should have 1.76455448. Okay, just write everything, don't round it, literally just write it down. Then we've got part B, which is separate. So work out the value of the reciprocal of 0.625. Now, because this is a calculator paper, and reciprocal is when you flip a fraction upside down, isn't it? What I'm going to do is I'm going to use my calculator to work out 0.625 as a fraction first, and then I can just flip it myself. So grab your calculator again. If you literally just type in 0.625 and answer, it should give you a fraction. If it doesn't, do you see you should have this kind of SD button here? That's normally how you can convert between different formats. So if it hasn't given you a fraction, maybe click that and hopefully it will do it for you. So as you can see, that is the same as 5/8. So 0.625 is 5/8. But we want the reciprocal, which is where you flip it upside down. So that would be 8/5. And that's it for the first one. We've got 3 marks for that. Okay, so question 2, write 60 as a product of its prime factors. So you can do it manually. I'm pretty sure there's a way to do it on your calculators, but all of us have different calculators. So if you want to look that up, go onto YouTube. There'll be definitely loads of videos of how to get the answers on your calculator. But I'm just going to do it manually because obviously they could ask you this question in the non-calculator as well. So we do need to know. So write 60 as a product of its prime factors. I'm going to use a factor tree. So I'm going to split it into, I'm going to divide, I normally divide by prime factors. Some people just divide by any numbers they can think of and then end up with prime factors at the end. I like to just keep it with prime factors. Normally I start with 2 just to keep halving everything. So if I divide by 2, that would be 2 and 30. If I divide by 2 again, that's 2 and 15. If I divide by, in this case now we can't do 2, can we? So I'm thinking obviously 5 and 3, isn't it? So the reason why I do it like that is because then everything on the left-hand side is a prime number. 2, 2, 5, 3. So then it says write as a product of its prime factors. Product means multiply. So I just need to write it as 2 times 2 times 3 times 5. Times 5. Now you can write it like that. You can also write it, I think they might call it index form. So you see how we've got 2 2's? That's effectively 2 squared, isn't it? 2 times 2. So you could also write it like this. They haven't really specified in this question, but sometimes they do specify index form, which means like adding any powers if you've got multiples. So that's it for product of prime factors. We scroll down to question 3. So, question 3, there are 48 counters in a bag. There are only red counters and blue counters in the bag. You can see here we've got a ratio for the number of red counters to the number of blue counters is 1 to 2. So I like to write the letters here just so I don't have to read this again. R to B, 1 to 2. Helen has to work out how many red counters are in the bag. She says There are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Is she correct? And give a reason. Well, what I normally do in this case, if they ask you if someone correct, then I just basically work it out myself, and if my answer is the same as theirs, then yeah, they are correct. If it's not the same as theirs, then they're incorrect. So Helen has basically worked out how many red counters are in the bag, so let's do that ourselves. So we're just sharing out 48 into this ratio 1 to 2. So when you're sharing out a ratio, you have to add together the two parts, so 1 plus 2 is 3, and that's what you divide by. So we do 48 divided by 3, which gives us 16. Obviously, you can put that in the calculator. That means we get 16 counters per part of the ratio. Now, in terms of red, it's only one part, isn't it? So red is just 16. If you wanted to work out blue, you don't have to in this case, but if you wanted to, you would do 16 times 2 because there are two parts, which is 32. And you see how those two should add up to the original 48. So we've worked out that red is actually 16. So is Helen correct? Well, no. And sometimes it's hard to explain why they're incorrect, so that's why I like to just write down the actual correct working, because that's normally enough in the mark scheme for an explanation. So if I look at the mark scheme, you have to obviously have to say no, but you have to give a reason why, which we've done at working there. So we've said that red is 16. Yep, they've accepted that as an answer. One of the list of the acceptable answers is there are 16 red counters. Obviously, you can see we've basically written that there. You could put in brackets if you wanted, not 24, because she said 24, didn't she? You could also say, in terms of the fact that she said it's a half, you could say, no, it's actually 1/3, isn't it? Because we divided by 3 instead of 1/2. You could say she's used the incorrect ratio. She used the ratio 1:1, basically, didn't she? Any version of that. You could say that if you added 24 and 48, you would get 72, and obviously that doesn't add up. You know, loads of different things. I like to just use working out because it's easier than actually trying to write an explanation. So no, there's actually 16, not 24 is my answer. Okay, question 4, we've got some inequalities. So they've said that we've got here, -2 is less than or equal to n, which is less than 5. N is an integer, so a whole number. Write down the greatest possible value of n. So in terms of this, it's saying that n could be -2, -1, 0, 1, 2, 3, and 4, because 5, it's not equal to 5, as it is less than 5. So the greatest one is 4. Then part B, we have on the number line below, show the inequality -4 is less than or equal to m, which is less than 1. So we don't need to solve this, it's already just in the base of m, so that's perfect. We can go straight ahead and draw on our circles. So whichever numbers you've got, that's where you draw circles. So we've got -4 and 1. And then we can, because it's a range, we can just draw a line between them. So let me grab my line. So there's a line between them. Now the other thing though is that you see how we had m is greater than -4 and equal to. So we can colour this in. If you've got equal to as well, you colour it in. Do you see how the top number, the 1, it's less than 1, so I'm not going to colour it in. So that's my answer to part B. Then let's just move this up for part C. So we're now told to solve this inequality. It's a linear inequality. So we've got 2/5 of g minus 4 is less than 6. So we're just going to solve it like any other normal equation, basically. Just copy the same symbol. So I want to get g on its own. So I've got 2/5 g. I'm going to move the 4 first. That means I need to add it because it's currently a minus. So if I add 4 to both sides, I now have 10. And then I want to move the 2/5. Now you can obviously do it just yourself without a calculator by multiplying by 5 and then dividing by 2. That's fine. But because this is a calculator paper, I might just use that. So we're going to do 10 divided by that fraction, because the fraction is currently multiplied by g, isn't it? So to move it, I need to divide, which is the opposite. And it gives me 25. So g is less than 25. Okay, just copy literally the same symbol. The only time that you might have to swap the symbol, the direction that it faces, is if you multiply or divide across the whole inequality by a negative, which we haven't done here, hence why I haven't had to swap it. Normally you can avoid doing that as well, so it's not very often, but just so you're aware, if you multiply or divide by a negative number in an inequality, you will have to swap the symbol and face it the other way. Okay, question 5. So here is a triangle and a rectangle. You can see we've got them in terms of some algebra sides. All measurements are in centimeters. The area of the triangle is 10 centimeters greater than the area of the rectangle. Okay, so that's an equation basically, isn't it? I need to translate that into an equation, because then it says work out the value of x. We can only work out x if we have equations and we solve equations. So the area of a triangle, let's first of all write that down. Area of a triangle is half base times height, isn't it? So base is 8 in this case. Height is 6. You might also do base times height over 2. Same thing. The area of the triangle is, now if you're not sure where you're supposed to put the equal sign, it's always where it says the word is. Okay, so that would be now. And then it says 10 centimeters greater, so that's like a 10 plus, isn't it? Plus 10. Greater than the area of a rectangle. So the rectangle here is just length times width, so that would be 5 multiplied by 4x minus 1. So I've literally just taken that sentence and I've translated it into an equation, and now I just need to solve it for x. So let's expand the brackets first. We've got half times 8. You can obviously type that into your calculator, but that's just saying what is half of 8, which is 4. You can obviously do this in one step if you like, but I'm just going to write it down. Then we've got 10 plus 5 times 4x is 20x minus 5. So then here we've got 24x. And on the right, we can add together the 10 and the minus 5, so 20x plus 5. Okay, now it looks a bit more normal. I want to get the x's together, so I'm going to subtract the smaller one, which is 20x. So minus 20x from both sides would leave me with 4x here, and then just 5 here. And now divide by 4. Let's move this up a bit. Is 5 over 4. You can obviously write it as decimal if you want to put it in the calculator, but you can also just leave it as a fraction. So that would be my answer. They've just said work out the value of x. X is 5 over 4. Okay, question 6. So last year a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. And then they've said the weight of the paper recycled to the weight of the glass recycled is 12 to 7. So I'm going to put P for paper and then G for glass, just so I can reference it more easily. Calculate the weight of the glass. Okay, this is just kind of a general arithmetic, percentages, ratios question. So first of all, I want to work out, it's kind of written in order, isn't it? I want to work out 57% of 800. Now, if you had a non-calculator paper, there's one way of doing it, but with a calculator paper, you just multiply the total, so the 800, by 57% as a decimal, which is 0.57. Now, if you're not sure how to do that, that's basically just over 100, isn't it? Any percentage over 100 makes it into a decimal. Okay, so that's what I'm going to multiply in my calculator. Grab our calculator, 800 times 0.57%. 0.57 is 456 kilos. So that is the total of the paper and the glass, isn't it? Now I can use this to share out my ratio. So the same as we did in the other question, when we're sharing out a ratio, we have to add together the parts in the ratio. So that would be 19 parts. You see 12 plus 7 is 19 parts. Then I'm going to do in my calculator 456 divided by 19 to work out how many kilos would be basically worth for one part of my ratio. 0.456, oh, make sure you type it in right, would be a good start, is divided by 19, which is 24. So that means 24 kilos per part of my ratio. Now, we're actually just looking at the glass, aren't we? You can obviously work out the paper from here, but we don't need to. We're only looking for glass. Glass is 7 parts. So that would be 7 parts multiplied by 24 kilos. So times your answer by 7, 168. Okay, that's literally just general arithmetic there. Okay, question number 7. A number, D, is rounded to 1 decimal place. The result is 12.7. Complete the error interval. So when it's rounded, in this case to 1 decimal place, it's effectively the same concept as upper and lower bounds, if it says rounded. So you just want a little bit above and a little bit below. Normally the way that I work that out is I put the number, 12.7 in the middle, and then I go, what's it rounded to? 1 decimal place. Okay, what's 1 decimal place above? Well, that's 12.8. What's 1 decimal place below 12.6? And it's not, those aren't the answers. It's then halfway between. So you see how you'd get 12.6.65 and then you get 12.75. Oh, not sure what happened with that 7. 7.5. Those would be your answer there. 12.65, 12.75. Now, some people think you need to put 0.4999 or whatever it is, loads of 9s, because I know that technically 12.75, if you were to round that to 1 decimal place, it would round up, wouldn't it, technically? But again, to look at this inequality, we're saying that D, the number D, is less than 12.75. It's not equal to, right? So it's anything just less than that. So that includes the possibility of it being 12.74999 to infinity, but you just don't need to write all the 9s because otherwise you just wouldn't get it. You wouldn't get them all. So do just put it for the next one up, even though you think, yeah, that should round up. It's fine. It's because of the inequality is correct. It's not equal to that. It's anything slightly less than that. Okay, so that's the error intervals in this case. Then we've got question 8. So Tamsin buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. So this is making me think, even though it's values of houses, this context is compound interest. I know it's not interest in terms of the context, but it's compounding, isn't it? Every year, another 4%, another 4%, another 4%. So that's the formula that I'm thinking I might need to use. So then we've also got Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has a greater value? Yes, this is the same as compound interest, just they've given it the context of houses. So all I need to do is use my formula for compound interest, which you might have memorized. I'm pretty sure it's on the formula sheet though as well. So I'm going to write it down. I mean, on the formula sheet, it might be written to a different way than I'm writing it, but you can refer back to the formula sheet on your own paper. Compound interest, or just compounding generally, doesn't matter the context, is you normally do what I'd call like the initial amount. I think, just going to let me write it nicely. I think on the formula sheet it says principal amount. You know, that's basically the same meaning, isn't it? So the initial amount, the starting amount, whatever they've started with, you multiply that by 1 plus, now it's plus because in this case you see how it's increasing. There are some contexts where it could be decreasing. So you might have seen something where it says the value of a car or the value of a house, more so the value of like a boat or something decreases over time. You would put a subtract here if that was the case. And then you do R, which I call it R, that is the percentage, over 100. That's again just converting it into a decimal, isn't it? To the power of the time. As I said, they might use different letters on the formula sheet, but it's basically the same concept. So we just need to do this but twice, one for Tamsin, one for Rachel. Okay, so T for Tamsin. Her initial amount is 150,000, isn't it? 150,000 multiplied by 1 plus, and now her percentage is 4, so 4 over 100, to the power of 2, because it's 2 years. That's what I would type in. Now, you might be okay with just working out as 1.04. That's the same as this bit here, isn't it? To the power of 2. That's fine, you can type it in like that as well if you can directly work it out. But technically the formula obviously has it all separate. So calculator, 150,000, make sure we've got enough zeros, times 1. Yeah, I normally type it in as 1.04, that's just how I do it. The power of 2, then we get 162,240, so let's write that down, 162,240. So that's Tamsin's value at the end of 2 years. Now we need to do the same for Rachel and see if hers is any more or less. So 160 now is our starting amount, our initial amount, multiplied by, again, 1 plus, but this time the percentage is 1.5. 1.5 over 100. And then it's still 2 years, isn't it? So power of 2. Type that one in. So 160,000. I would normally type it in like this, but again, you can put it in the brackets as I've written down if you want. So we get 164,836. Okay, now they actually said at the end of 2 years, whose house has a greater value? Well, you just obviously have to look at the two numbers, which one is greater. Clearly it's Rachel, so you do need to indicate that. So I would write down here like therefore it's Rachel. Therefore Rachel, just so it's really obvious. Okay, so it's basically compound interest, but in a different context. But as long as you can recognize that they've given you this initial amount, they've given you a percentage for each year, and then they've given you a time frame of multiple years, that's basically compounding, isn't it? It's all the same. Okay, so let's look at our next question. Question 9, we've now got cumulative frequency. So on this one, you will have question 9 on this page, and on your next page, there should be a graph page. So the cumulative frequency table gives information about the ages of 80 people working for a company. Now they've already done the cumulative frequency table for you. You don't need to work that out. Sometimes part A is to work out that table, isn't it? They've already done that for you, so you don't need to worry. On the grid opposite, draw a cumulative frequency graph for this information. So what I think I'm going to do is copy and paste this, because mine's obviously on a different page, isn't it? So if I try and print screen that table, obviously on yours, you should be able to look at both pages at the same time. So I'm just going to paste this here. Hopefully you can see that table. Now, obviously the cumulative frequency column is fine. That's just the y-axis, isn't it? But in terms of the, in this case, age, in terms of the x-axis, which do we plot? Because it's obviously a range, isn't it? Now it's a graph. It's not like a bar chart or anything. So you just need to remember, if I get my highlighter, you always, for cumulative frequency, you always plot the second number in the inequality in the range. So like the right-hand side. So these are the ones we're going to plot. First of all, also, because can you see it's the other one is all 20. So there's no point plotting all of them on 20. But also sometimes people think it's a midpoint, and it's not. It wouldn't work out to be a midpoint because you'd end up only using half the graph. So that would, first of all, seem odd. But secondly, midpoint on the graph is when you do a frequency polygon, which is a completely different topic. They sound similar because they both have the word frequency, but that's for frequency polygons, okay? Not for cumulative frequency. So we're plotting this right-hand side here on the x. So obviously you just go through and plot it. That's fairly straightforward. So 30 and then up to 20. So 30 here up to 20. Obviously just double check any of the scales. 40 is then at 48. There's that. Oh, try that one again. There. 50 is then at 64. Obviously it should be constantly increasing, right? Because it's cumulative. It's adding more and more every time. So if your graph went back down again, something's wrong. So 50 at, what did I say? 64. 60 at 75. And obviously the last one should be the total. Do you remember how we circled it? If I go back, we circled 80 people. The top of your graph should always be that total. There. You see that's constantly increasing. Now you obviously need to join it up. It is a curve, okay? So don't use a ruler. Just try obviously with a pencil best you can to draw a curve. I normally start from the 0 now, so it's obviously going to be interesting to try and do this digitally. But yeah, you do your best to draw an accurate curve or you join them all up. So let's see what I can do. I have to do it in different parts. That's a bit wonky, isn't it? Oh, this is not going very well. Obviously in real life you'd be able to do it much better than I can. Right, that will have to do for that one. There. Yours hopefully won't be as shaky as that, but it should obviously look like a nice curve that's increasing. So that was part A. If we come back, there was also a part B. So part B, now we need to use our graph to find an estimate for the median. Okay, this is really, it's only 1 mark. This is really nice. So median means the middle, doesn't it? 50%. So we know that our total is 80, isn't it? Be careful that you read it off the graph. Sometimes it is like, for example, the total might be 78, but it looks like the total's 80. So just double check in the actual table on, or if they've written it in the question, what the actual number was. So the total is 80. The middle of that is obviously 40, isn't it? So we're going from the cumulative frequency side. Person number 40 is what we're looking for. So I get my ruler at 40. I'm going to go across. Let's see if we'll draw a line across. And then wherever it hits, obviously, your drawing. And then you go down. So mine has come out at, that looks like to be exactly 35. And that's in terms of years, isn't it? So if I come back here, do you see how it's in years? So you know which axis you're supposed to be reading off. So 35 years is what I've got. Now, they will give you a slight, kind of quite small range of possible answers, just because drawing that curve, everyone's will be slightly different. Okay? It's not a very big range, because obviously your actual coordinates should all be the same, but there is a range. Now, the range is actually, I can tell you from the mark scheme, as long as you've got anything between 36 and 38, obviously mine's not within that range, because obviously I drew a really bad curve, but in real life, when I did it on a piece of paper, I think I got 37, so that would be within the range. So as long as you've got 36, 37, 38, then that's perfect. And this is the exact same way that you would do upper and lower quartile as well. Sometimes they ask for that. You'd obviously do 25% and then 75%. Okay, question 10. So a biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time, obviously between 1 and 6. So Gethin throws the dice twice. So I'm already thinking something to do with probability trees here. They've not obviously given us space really for one, but you could use one if you wanted. When there's 2 events, I normally use a tree. So what I mean by 2 events is that he's thrown the dice once, that's like the first throw, and then he's thrown it again, so that's like throw number 2, isn't it? Second throw, so 1 and 2. So work out an estimate for the probability that the dice will land on 6 both times. I like to draw it as a tree just because I like to visualize it. If you're happy to do it without visualizing it, that's absolutely fine as well. So it's saying landing on 6. So for example, this could be my tree. This is like the first throw, isn't it, of the dice. We want to land on 6, or I'm just going to put like not 6 because I don't need to write down the other 6 or the other 5 ones. That would be way too many to draw. So what's actually my probability that the dice will land on 6? I need to work that out. So if we have a look here, landing on 6 happened 15 times, and then out of the 60 total, isn't it? So you see how that would be? The probability of getting 6 is 15 out of 60, or if you want, that would simplify it to 1/4. So either of those two, you can use those. Let's just put 1/4 to be simple. Then the second throw, we want him to land on 6 again, don't we? It's obviously, throwing a dice doesn't really, how do I explain this? The first time you throw the dice, whatever you get, whatever number, won't affect the probability of getting that number again, will it? It's going to be the same probability, isn't it, every time? 1/4. So that's our second throw, isn't it? And then obviously this would technically be not 6, which we don't need to worry about. So they're both the same probability, and then we would be saying, right, we want to get a 6 first time, and we want to get a 6 second time. And if you remember, between branches on probability trees, we have to multiply, don't we? So the probability of getting 6 both times would be 1/4 times 1/4. which is 1/16. Obviously, you can put this all in your calculator if you want, but I think some of it is, you can work it out yourself anyway, can't you? Up to you. So 1/16 would be our answer, or if you did use 15/60, I'm assuming your calculator would have obviously simplified it anyway, but if you did use that, and you didn't simplify it, just so you know, the other option would be 225 over, what was it, 3,600. That's the same exact probability, just unsimplified. So if you write either of those two things, that's the correct answer. Okay, they haven't asked you to simplify it. Okay, part B. So Sally is going to throw the same dice n times and record the number it lands on each time. So we don't know how many times she's going to throw it. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? So it's basically any time that you're trying to figure out probabilities by doing, multiple tests. In this case, they threw the dice 60 times. It's always more reliable to do it as many times as possible. So when they say, what can you say about the value of n? All we need to write down is that it should be more than 60. Because Sally wants to be more reliable than Gethin. She wants to have more reliable results, which means she would have to do the test more times. So you can say, again, there's different ways to write it. There's obviously 3 lines, so you don't need to fill them all in. I would say n must be bigger or larger, or whatever you want to say, than 60. You could probably write it as a inequality as well, I would imagine. N is greater than 60. You could probably write it just like that without even writing any words. Something to do with that, okay? N must be bigger than 60. Now, I don't think they'll let you choose a number. Like, I don't think you could say n must be 65. Like, I don't think you can say that. You have to just say it has to be something bigger than 60. Because we technically don't actually know, do we? How many times? So the examples they've given is n must be greater than 60. She must do it more times than part A or than Gethin. N must be bigger, e.g. 100. They've said example 100. So hopefully you get the gist of what we're saying here. It has to just be bigger than 60. Okay, question 11, really nice one here, just straightforward. Use algebra to solve the simultaneous equations. These are both linear, so as in there's no quadratic, there's no square, is there? It's just x, it's just y. So you can choose. You can either use elimination method or substitution method. It's up to you. That's just a personal preference. I tend to lean towards elimination, but that's just my preference. So that's how I will show you how to do it, but I do have videos, if you want to have a look in my channel, I do have videos on both methods, so you can check them both out. So, elimination method, what we need to do is eliminate one of the letters, because you can't solve an equation if it has 2 letters, right? It has to only have 1. So then I have a look at the numbers and I go, sometimes people just say, I'm always going to eliminate the first letter, like x, for example. I like to have a little look at what values they've given me specifically and which one might be easier. In order to eliminate the letters, I need to have the same coefficient. So for example, x needs to be both the same number or y. In this case, to make x the same, I would have to use 6x, wouldn't I? The lowest common multiple is 6x, which means I would have to change both equations. And then if I look at y, the lowest common multiple would be 12, which also means I'd have to change both equations. So in this case, there's not one that's easier than the other. It's just up to you. So I'm going to make x the same. Let's just do that. So in order to make x the same, as I said, I need to make them both 6x. And when you make them, obviously when you change one part of the equation, you have to change the whole thing. So the first equation, I'm just going to label it equation number 1. To make that 6x, I'd have to multiply by 3, wouldn't I? So the whole equation times by 3. So that would be 6x plus 6y times 3 is 18y. 5 times 3 is obviously 15. So that's my new version of equation 1. Equation 2, I would have to multiply by 2, wouldn't I, to make it 6x. So 6x minus 8y minus 24. Now do you see how I've got x? They're both the same. That's what I want. So I can always eliminate the x's because they're the same number. So then you have to figure out, in order to eliminate x, do I need to add or subtract the equations? Now there's actually an acronym for that. SSS means same sign subtract. So if they're the same sign, and I don't mean this because those signs are relating to the y's. What I mean, it's kind of hard in this case because you can't see the signs, is technically the symbols in front of the x's, well, they're technically both positive, aren't they? Which means they're the same symbol. It would work also if they were both negative. If it's the same sign, you subtract. Okay? So we're going to subtract these equations. The other one is DSA, which is obviously harder to remember. If they're a different sign, you add. Let's say if you had made y the same number, then you would add because it's plus and a minus. But because I've chosen x, I need to subtract. So just be careful when you're subtracting because we're going to have some double negatives as well. Obviously 6x, take away 6x is 0. That's the whole point, isn't it? I want to eliminate x. So then I've got 18y, subtract minus 8. You can always write it out separately if you find that helpful. You see how that's a double negative? So actually that would end up being plus, wouldn't it? Which is 26y. And then 15, subtract, again, a negative 24. That would be another double negative, wouldn't it? So that would give me 39. Now I've got an equation with just y, so I can just solve it by dividing by 26. Now you might want to put that in a calculator, or you might have already figured out what it is. It's obviously not a whole number. Let's just put it in the calculator for demonstration. So 39 divided by 26 gives us 3 over 2. You could obviously write it as 1.5 if you like. That's just personal preference. I normally like to use fractions. So we've got y. That's the hardest bit. Once you've got one of the letters, the second one is so much easier. So you're going to take your y, which is 3 over 2 or 1.5. Write that down so you can see that. Or 1.5. And you're going to substitute it back into one of the original equations. You can choose whichever one. I normally try to look at which one looks easier, but you can just pick whichever. I'm probably going to choose equation 1 because I feel like at least there's no negatives. So sub y equals 3 over 2 into equation 1. So that would be 2x, because I still don't know what x is, plus 6 times 3 over 2 is equal to 5. And now do you see how I've got an equation with just x? So now I can solve that. So let's use our calculator to work out 6 times 3 over 2. So our answer was 1.5, wasn't it? 3 over 2 times by 6 gives me 9. So that is 2x plus 9 equals to 5. Now that looks a bit more normal, doesn't it? I'm obviously going to subtract 9, which will give me minus 4. I don't know if you can see all of this. Move up a bit, shall we? And then obviously you're going to divide by 2. So that would be minus 2. Okay, make sure you obviously get a negative correct if it is a negative. So x is negative 2, y is 3 over 2, or if you wrote it as 1.5, that's also absolutely fine. Okay, question 12. The points A, B, C, and D lie on a circle. Obviously the centre is O. A, B, C, D is a rectangle, as you can see. They've obviously labelled AB as 8, BC as 10. Work out the circumference of the circle and give your answer to 3 significant figures. So first of all, circumference, we need to know, how would you actually work that out? What is that formula? Now you might use pi times diameter. That's the one that I use. Or you might use 2 pi r. Also fine. Just make sure you're aware of what your formula is. Because then it will tell me what I need to know. What am I trying to figure out here? Well, we basically need to know either the radius or the diameter of the circle, don't we? Which they relate to each other, don't they? The diameter is equal to 2 times the radius. So it's telling me I need to work out either the radius or the diameter. I think in this case it's easier the diameter. Just because if I were to draw the diameter from using my rectangle, if I draw it here, you can also draw it B to D, that's also fine. That would be the diameter, wouldn't it? AC. And then do you see how, because I know this is a rectangle, this is 90, I've created a right angle triangle where I do know the other 2 sides. So in order to work out the diameter, I just need to do Pythagoras. So Pythagoras, hopefully you know this, but I think it's also on the formula sheet. a squared plus b squared equals c squared. Now, c is always the hypotenuse, which is the diagonal. So this one is c, isn't it? And then a and b, it doesn't really matter as long as you've got c in the correct place. So we've got 8 squared plus 10 squared equals 2. I'm going to label it as AC just so you know which line I'm referring to. And I want to know AC, don't I? So let's get my calculator. Where has it gone? 8 squared plus 10 squared is 164. Now obviously I would need to then square root that, wouldn't I? Ooh, square root answer. They've simplified it to 2 root 41. You could obviously just write it as root 164 if you like. So we've got 2 root 41 is AC. So that's my diameter, isn't it? If I put equals diameter. Now because I've worked out the diameter and I like to use pi times diameter, I just need to multiply that by pi. If you use 2 pi r, you would obviously have to divide the diameter by 2 and then put that into your formula. Also fine. Just make sure you know which one you're doing. So the circumference is pi times 2 root 41, which in this case they've asked for it in terms of significant figures, which is like decimals. So I'm going to actually multiply that in my calculator. So take my answer, multiply by pi. There's my decimal answer, 40.232 ... Now they've asked for significant figures, 3 significant figures, so that would be 40 is 1, 0 is number 2, 0.2 is number 3, and if I look at the digit after that is a 3, so I can round it down to 40.2. 0.2. That's my circumference. Okay. So it's just a bit of Pythagoras as well as circles. Okay, question 13. ABC is a triangle. You can see we've got some sides, some angles, and it's like a scalene triangle, isn't it? It's not like a right angle, it's all a bit random. So I'm already thinking, that's going to be something to do with trig, but not SOHCAHTOA, because it's not right angle. They've asked us to calculate the size of angle BAC. So which is that? B to A to C. So that's this one here. That's the one we want, isn't it? Okay. Correct to 1 decimal place. Fine. So yeah, immediately I'm thinking this is obviously either cosine rule or sine rule because of the type of, first of all it's a triangle, but the type of triangle is not a right angle triangle, and I've been given a mixture of sides and angles. So we just have to then figure out which one it is. Now, a sine rule is where you have 2 pairs. You have 2 angles, 2 sides. Obviously one of those is missing, right? But you have 2 angles, 2 sides. And cosine rule is where you have 3 sides and 1 angle. Again, one of those is missing. In this case, it kind of looks more like sine rule. However, the sine rule, it has to be pairs, doesn't it? So for example, 18 goes with the 70, doesn't it? That's side B because they're opposite. But do you see the problem that I have is that then 15 goes with an angle that I don't know. And also the angle I want to know is with a side I don't know. So I don't actually have 2 pairs yet. So what I think I'm going to do is probably 2 steps, isn't it? I think what I could do is I could use sine rule to work out the angle C here. And then because it's a triangle, I could subtract them from 180 to get the one I actually want. So that's what I'm going to do. I've obviously labelled the sides with the opposite letter to the angle. Because I'm trying to find an angle, I need to use sine at the top of the fractions. Obviously, again, look at your formula sheet, it's on there. So sine, let's call it C, because that's angle C, isn't it, is over 15 as a side. And that would equal to sine of the angle B, which I know is 70, over the side B, which is 18. And then, obviously, because I just want sine C or I just want the angle C, I need to move the 15, don't I? So I just multiply by 15. That's like a normal equation. Multiply it across. So in my actual calculator, I can put sine 70 over 18 multiplied by 15. Now, though, do you see how that gives me sine C? I just want to know the actual angle. So in reality, whenever we're working out an angle with trig, so whether that's SOHCAHTOA, sine rule, cosine rule, anything, trig, if you're working out an angle, you always do the inverse, don't you? So what I mean by that is when it has the little -1. So bring back my calculator. If you press shift and then sine, do you see how I get the -1? That's the inverse. So that will cancel out this sine here, just to leave me with angle C. And then within that, I'm going to put normal sine, because that one does have an angle, 70, over the 18. And then multiply that by 15, close the brackets. That is a fairly reasonable number, isn't it? You know it's going to be something between kind of 30 and 90, really, isn't it? So 51.543, I'm just going to write down a few of those decimals. Oh, let's write it in the colour black. So 51. So angle C is 51.543 ... degrees. Now, just remember that that wasn't actually the final answer, was it? That was this one here. The last thing I need to do is work out my final actual angle they've asked for, which I think when you're doing trig, because trig is obviously quite complex, you almost forget how to use the basic information about angles and triangles. To work out this missing angle here, I've already got the other two. So all I would need to do now is just 180 minus both of those other angles, wouldn't I? Let's move this up so you can see. So the last thing would be 180 minus the 70, which was the angle at the top, wasn't it? Plus the 51.543 ... That will give me angle BAC. So let's use my calculator. Obviously, try and keep this here just so you have all the decimals. So I'm going to do 180 minus 70 plus, I'm going to put answer, so it copies all of those decimals. That gives me 58.456, and now, because this is the final answer, I can now round it. They said to 1 decimal place. So that would be 58.5, wouldn't it? There we go, 58.5, 4 marks. Okay, question 14. So, we've got algebraic fractions here. Show that x squared minus x minus 6 over 2x squared minus 5x minus 3 can be written in the form ax plus b over cx plus d, where a, b, c and d are integers. This is just basically a simplifying question. Simplify the algebraic fractions, and the way that we simplify algebraic fractions is we try to factorize as much as we can. In this case, we've got 2 full quadratics, which means that I should be able to factorize into double brackets at the top and the bottom. So let's start with that. So factorizing, obviously that's x squared, so just x and x. We need 2 numbers that multiply to make 6 and add up to make, that would be -1, isn't it? I normally do the symbols first in this case, so because we're multiplying to make -6, we're multiplying to make a negative, I know that 1 is plus, 1's minus. And then factors of 6, you've obviously got 1 and 6, 2 and 3. Which ones would add up to -1 when obviously 1's plus, 1's minus? So I'd probably do 3 and 2 because the difference is 1, isn't it? And then 3 would have to be the negative because that's the bigger one. Plus 2 would make -1. Once you've factorized one of them, it's normally going to be a clue because then the second, well, in this case, the second quadratic, the denominator, should have one of the same brackets. You don't know which one necessarily, but it should have one of the same. Because ultimately we want to be able to cancel them out, don't we? So this one's a bit more complicated because it's obviously a 2x and an x. So this one here is going to be the same as one of the top 2. So at least it kind of gives you a bit of guidance that, you know, to help you figure out what you're looking for. Now again, we're multiplying to make a negative. So it's going to be a plus and a minus, but I can't, oh, that was a really dodgy multiply. I can't write them in because I don't know which is plus and which is minus, because obviously it's not just x and x, it's 2x and x. So I'm going to leave that kind of over here. 1's plus, 1's minus. And then factors of 3. Well, luckily 3 is a prime number, so I can only choose from 1 and 3. So we know it's going to be plus and a minus. We know it's going to be 1 and 3, but which way round does it go to add up to -5? So I'm thinking we need to multiply 3 by 2, because that would make 6. and then 1. And then how do I get negative 5? Well, I need to make it negative 6 plus 1. And it also helps you because you know it had to be a 3 here, then you know it's probably going to be a negative as well, so it matches. Because ultimately, with algebraic fractions, you want to be able to cancel out some brackets. So you know that you need to have a bracket at the top and the bottom that are the same. So we're left with x plus 2 over 2x plus 1, which if you have a look at the format they gave us, that is correct, isn't it? I feel like it's probably a bit misleading because there seems to be a number in front of the x, but technically it's 1x, isn't it? We obviously just don't need to write the 1. Okay, so that's just your answer. Okay, let's have a look at question 15. Oh, another really nice one, quite straightforward. Here are the first 4 terms of a quadratic sequence, 3, 9, 17, 27. Find an expression in terms of n for the nth term of this sequence. So as long as you've memorized how to do this, you just have to recite it basically, don't we? So a quadratic sequence, the way that I do it is you have to work out differences. So you've obviously got your actual original sequence there. You want to first work out what we call the first row of differences, first difference. So between them, you see how the difference there is 6, between 9 and 17 is 8, 17 and 27 is 10. Then you have to work out the second difference because the first difference won't always be the same amount. The second difference should then be the same amount. You see how that's 2, and then the second one is also 2. So you start off by doing this. The next bit is that you just have to have these memorized. This is how I do it. Start off with the second difference, so in this case 2. That one will equal always to 2a. So 2a in this case equals to 2. Do you see how then I can solve that to make a? A is 1. And then we jump up, so you then work backwards along this left-hand side. It has to be the left-hand side. The first one of the first differences, which in this case is 6, is always equal to 3a plus b. And then do you see how, because we know what a is, I can sub that in. So 3 times 1 plus b. You have to do it in this order because obviously you can't solve it if you don't know both or at least one of the letters. So 3 plus b is equal to 6. So see how b would be to 3, wouldn't it? And then the last one is then jumping up again, this time to the first term in the actual sequence. Has to be the first term. Let's get another colour, shall we? Orange. This one has to equal to a plus b plus c. And then again, you already know a and b. So you can substitute those in. So a is 1, b is 3 plus c. And then you solve that. So that's 4 plus c. So c is obviously minus 1. Now the reason why we want to know that is because all quadratics, and in this case it's got a context, but are an squared plus bn plus c, isn't it? So I've worked out what a, b and c are. So a is 1, so I just write n squared, plus 3n for b, and then instead of plus c it's obviously minus 1. So there's your answer. So as long as you memorize those 3 bits, so the 2a, 3a plus b plus c, if you memorize those, then it's really easy. Okay, question 16, we've got histogram. The histogram gives information about the number of hours some students used their phones last week. And you can see that they've said the histogram is incomplete, we're missing something over here. They then told us that 28 students used their phones for between 30 and 40 hours. That's one that we already know. So this bar represents 28 students. And then they've said that 24 students used their phones for between 40 and 60 hours. So that's the one we are obviously going to need to draw. Use this information to complete the histogram. Okay. So you can see we don't have the frequency density scale. So that's why we've been told this other thing. So when you're not given frequency density, I tend to work out the number of squares. So for example, do you see how across between 30 and 40, that's 10. And then up, we've got 10, 20, 25, 26, 27, 28 up. So the number of squares, if you just multiply it because it's a rectangle, is 280, isn't it? Do you see how for that bar, 280 squares is the same as 28 students? And then I can use that comparison to help me work out, well, how many squares would I need for 24 students? You can obviously see they've just times it by 10, haven't they? So therefore, 240 squares would be enough for 24 students. So I need to draw a bar that's 240 squares. Now I do know the width of the bar, don't I? Because it has to be from 40 to 60. That's 20 squares along, isn't it? So I just need to work out, well, how many up? So if it's 240, I'm going to divide that by the 20 squares across. So grab my calculator. Obviously you might be able to work out yourself anyway, that's fine. 240 divided by 20 gives me 12. So I just need 12 squares up. So then I can count them. So that's 5, 10, 11, 12. So you see how that's like here. Now let's get my lines. Draw across at that point. And then down obviously at 60. Okay, that would be part A. Now let's look at part B. So no student used their phone for more than 60 hours. So they're just telling you that there's nothing else on that histogram. It stops at that point. Work out the total number of students. Okay, well, let me rub out that. So we know that this is 24, isn't it? We know that the middle one here is 28. That means that I just need to work out the other two bars. So we already know that 10 student, well, one student is equal to 10 squares. 10 squares is one student, isn't it? So we can just work out how many squares are in both of these. So this one here, 20 to 30, is obviously 10 squares along. 10, 20, 30, 36, isn't it? So you see how that one's 360 squares? Well, we know that therefore it would be 36 students, wouldn't it? And then this first one is 20 across. And how many have we got? 10, 15, 16? So 16 times 20 is 320. And that would be 32 students. Now all we need to do is add up all four. So we've got 32 here, 36 here, 28, 24. So let's add that up. So we've got 32 plus 36 plus 28 plus 24, 120. There we go. 120 is the answer for that one. Okay, question 17. This is now iteration. So show that the equation x to the power of 4 minus x squared minus 5 is equal to 0 can be written in the form x is equal to the fourth root of x squared plus 5. It's only 1 mark, so all you need to do is kind of look at both of them and see how they've rearranged it. How have they gone from this first version to the second? So you just have to try and figure that out. How have they rearranged it? Well, it looks like they've added both x squared and 5, haven't they? They've moved those across, so I'd probably write that down. So x to the power of 4 equals x squared plus 5, just so that they can see there's some kind of middle step that you figured out why. And then you see how they've obviously just like fourth rooted, haven't they, to get x on its own. X squared plus 5. So I would write that. I think that's enough for 1 mark. And then part B is now what hopefully you can clearly see as iteration. They've said starting with x0 being 1.5 use the iteration formula. So xn plus 1 is equal to the fourth root of xn squared plus 5 3 times to find an estimate for a solution of the original equation, x to the power of 4 minus x squared minus 5 equals 0. So this bit, I feel like this can be quite confusing. It just basically is, it's almost like a sequence. You're going to substitute in the original, so in this case 1.5, to here to get your answer for x1. And then your answer for x1, you're going to substitute in again to get your answer for x2. So there's quite a nice way to do it on the calculator, actually. I'll show you. So calculator. So first of all, before you even type in the equation, oh, where's it gone? Type in the starting number. So 1.5, press equals. Now, see how that's now your answer. Then you can type in the equation, the formula, but put answer wherever they've said xn. Okay, so fourth root, so I'm going to do that. So 4, answer, and then that is squared, isn't it? Plus 5. The reason why I do that is because then I can just press equals 3 times. And I just have to write down the values from there. So when I press equals, the next answer, so x1 is this. Now I would just write down all those digits, basically. And normally for the first one, I'd probably write down the equation just so that they can see that you knew what you were doing. So like I obviously substituted in 1.5, didn't I? Plus 5 equals, and then my answer from the calculator. I would write down all those digits basically. So that is 1.640909017. And then for x2, you don't need to obviously rewrite that because they already know that you know what you're doing. Come back to the calculator and just press equals again, and then write down this new number. And then we'll do it once more for x3, okay? So the next number is 1.665398002. And then finally x3. I've done these 3 because they said 3 times, right? Normally it is 3 times. Equals again, and it's changed once more. 1.669763088. Now, they've said use this formula 3 times to find an estimate. So one answer. So in this case, you just choose the final one. So the x3. Okay, so that would be my answer. And I would just, again, just write all the digits down. That's what I would recommend doing. So my answer, my estimate is 1.669763088. Sometimes they just ask for the values of x1, x2, x3, and that's your answer. Sometimes they ask for like an estimate, one answer. Choose the last one. Now they have said that was the kind of main answer that they wanted, but they have said that they will accept either anything between 1.6697 to 1.6698. So if you rounded it, they will accept anything between those values, or they will also technically accept 1.67, which is if you were to round it like here, isn't it? But I personally just think it's safer just to write the whole answer out. That's like the main answer that they asked for. Okay, question 18. So we've been given 2a to 5c is 6 to 25, 4b to 7c is 20 to 21. Show that a plus b to b plus c is 17 to 20. This is one that would definitely throw me off if this was in my exam. I feel like ratio is quite hard, especially at the end of the paper. I think there's different ways to do it, but the way that I looked into it was... I don't know if you've been shown this. I feel like I didn't see this when I was in school. But there's a way to convert these into equations. So I normally like to write them vertically personally. So let's say 5c, 2a to 5c is 6 to 25. There's 2 ways to write them as equations. If you cross multiply, you can put them equal. So what I mean by that is 2a times 25 is, well, let me write it like this. 2a times 25 is equal, and then you multiply the other side, but opposite. Has to be opposite. Just have to remember that. 5c times 6. And then obviously if you expand that, you get 50a equals to 30c. See how now that's an equation. The other way is you just put them as fractions. So I'm pretty sure it's like 2a over the 5c, and then you keep it the same, so like 6 over 25. And then you see how you would cross multiply if you needed to. You can write either of those. I think this one's more straightforward though, in terms of an equation. So I did that for both. So let me rewrite this one out. Obviously then I could simplify this, couldn't I? To 5a, if I divide by 10 on both sides to 3c. And then the other one, let's do the other one. So 4b to 7c is the same as 20 to 21. Again, cross multiply into an equation. So we should get 84b is the same thing as 140c. And then if you were to simplify that, I think you can divide both by 28. That's the most simplified. 3b is 5c. So I've got two equations. Then what we can do is you can kind of undo that and put it back into ratios. So if we do the literal opposite, do you see how, let's do it on this one first, a to c would be the same as, and then you swap them over, would be the same as 3 to 5. Now, I mean, obviously a faster way would be just dividing both by 2 and both by 5. That would be much faster actually. And the same here, divide by 4 and divide by 7. You could also do that. And then this one would be b to c, which would be 5 to 3. That's the way that I looked into doing it, just so you have a reason why it works. But also, as I said, if you want to just literally divide both, so as in divide the a side by 2, so that you divide that by 2 and then divide that by 5, you can also do that. If that makes sense to you, just to go straight into that, absolutely fine. So then I've got these two ratios where it's just a, c, b, c. And what I want to do is get basically a 3-part ratio. So a to b to c. Now that bit's kind of easy because you just look at where they overlap. See how they both have c. And you have to obviously find the lowest common multiple for that. It's kind of like with fractions when you find a common denominator. So the lowest common multiple of 5 and 3 is 15. So I'd have to change them both to be 15. So if that becomes 15, you see how I'd also have to change the other side. That would be times by 5, which I also do on the other side. So that would be 25, wouldn't it? And then this one becomes 15 by timesing by 3. And then, so therefore times that by 3, 9. So then a to b to c is 9. B was 25, wasn't it? And c is 15. So I've combined them. Now the last thing is then just adding them, because you see how they've said a plus b and b plus c. So because they're all in the same scale, I can add them. So a plus b is obviously 9 plus 25, which is 34. And then b plus c is 25 plus 15, which is 40. I think this is too low down. Let me move it again. There you go. And then just put those together. Now the only other thing is they obviously want us to simplify it, so that would be 17 to 20. Okay, it was quite complicated on that one, but I think if you don't worry with the equations, if you just go straight into dividing them and you go straight into this step here, then from there it's okay. But yeah, ratio is quite a complicated one at the end. Okay, question 19. ABC is a right-angled triangle. They've given us obviously 2 sides, and then we want to calculate the lower bound for the size of the angle marked x. So they've said that AB is 9.3 centimeters, but correct to the nearest millimeter, and AC is 12.6 centimeters, correct to the nearest millimeter as well. Calculate the lower bound for the size of the angle. So obviously to calculate the size of the angle generally is just SOHCAHTOA, isn't it, trig? But it's harder, it's obviously question 19 because of these upper and lower bounds. So first of all, when you get an upper and lower bounds question that you have to use a formula for, you always work out the upper and lower bounds of the original measurements, so these two, and then before you put them into the formula. So I need to work out the upper and lower bound of AB and AC. So let's write that, AB, 9.3. It's kind of how I did the, what's going on with my pen there? It's kind of how I did the error intervals one. So to the nearest millimeters, I do 1 millimeter above would be 9.4. If you find this kind of hard because it's obviously centimeters and then they want nearest millimeters, you can convert them into millimeters if you want. And then 1 millimeter below would be 9.2. And then halfway gives us, so that was obviously the lower bound. And then this one here is the upper bound. So you don't have to write it out like this. Again, if you can visualize it yourself, that's fine. But I like to look at it like this. So we get 9.25, 9.35. Oh my goodness, 35. There we go. Then I do the same for AC. 1 millimeter above, 12.7, 1 below, 12.6. Lower bound is there, upper bound is here. So that would be 12.55, 12.65. Okay, now that we've got both of those, we need to work out, because they've only asked us for the lower bound of the size of the angle, haven't they? So we need to work out which of these do we need. So first of all, now I'm going to look at how do I work out the size of the angle in the first place, using obviously SOHCAHTOA. So opposite is 9.3, hypotenuse is 12.6, so I'm going to use sin, which our formula for the angle, sin of the angle x, would be opposite over hypotenuse. So you see how that's divide? When we divide, you actually need a combination, like one upper bound, one lower bound, for example. If you're multiplying or adding, you use either both upper bounds to find the upper bound, or both lower bounds to find the lower bound. But when you're dividing or subtracting, you actually need to use a mix of the two, again, which is why they put this at the end of the paper. So we want to find the smallest possible answer. So which combination would I divide to get the smallest possible answer? Well, I would want to divide the smallest number by the biggest number, wouldn't I? That would give me the smallest answer. So the lower bound, the opposite was AB, wasn't it? So the lower bound of AB divided by the upper bound of AC. So those are the ones I'm going to use. So lower bound of AB is 9.25. Upper bound of AC is 12.65. That's what I'm going to put into my formula. Okay, now we obviously already saw this when we looked at the sine rule. When we're trying to find an angle with trig, it's always the inverse, isn't it? So I'm going to do in my calculator sin inverse of that fraction. So shift sin gives me the inverse, 9.25 divided by 12.6, oh, not 11.66, 12.65, let me do that again. 12.65. And I get 46.989. They haven't told us actually how to round it, so I'd probably put a few decimals just to be more specific. 46.989. That's what I would write. So work out the upper and lower bounds of the measurements first, and then figure out which ones to put into your formula second. Okay, question 20, we've got vectors. So ORT is a triangle. OT is A and RT is B. They've already labelled that, so that's fine. M is the midpoint on OR. Oh, sorry, M is the point on OR, not the midpoint. A lot of the time M represents the midpoint, so we have to be careful we read it correctly. M is the point on OR such that OM to MR is 2 to 3. So that's like 2 to 3. These aren't vectors, right? This is just the ratio, just so we can see it. Express MT in terms of A and B. So I'm obviously going to draw that line on first. So you can always draw any lines that you find helpful, that's fine. So that's MT. We want to work out that one. So working out vectors, this is called vectors geometry because it's a shape. I just imagine like, okay, I have to start at M, I need to get to T. I obviously can't walk along the line MT because I don't know it. I have to kind of find a route elsewhere. So you could either go M to R and then down, or M to O and then across. It doesn't really matter which, you'd get the same answer, whichever you prefer. So I'm probably going to go up and down. I mean, like I said, it doesn't really matter. So I know RT, but I would need to know MR. See how I'm kind of working backwards to figure out what I actually need to know? I need to know MR. And to know MR, I need to know the whole of OR. So that's where I'm going to start. O to R. Imagine you're stood on O. You have to go across to T, wouldn't you? And then up to R, because those are the only ones that are defined. So A, because we're going correctly in the correct direction. But then you see how I'm going the wrong way up to R? So I'd have to do minus B. If you're going the wrong direction, against the arrow, you have to put a minus. So that's the whole of OR is A minus B. Now, M to R is just a smaller version of that, isn't it? It's a section of that. So that's what I'm going to use. My ratio. So you want to convert ratios into fractions. You just put the ratio as the numerator. And the denominator is the two added together. So that would be 5s, 2/5. And the other side would be 3/5. Now, because I personally have chosen to go M to R, now I am going in the same direction as O to R, so that's positive, but it would be 3/5 of that line, wouldn't it? It's not the whole line O to R, it's only 3/5 of that line. And now I can then work out M to T, because I go M to R, which we've just said is 3/5 A minus B, and then I go the correct direction along R to T, which I know is just B. So that's an expression for M to T. However, they have said give your answer in its simplest form. So at this point, it's just algebra, isn't it? Expanding, simplifying, collecting like terms. So expanding that would be 3/5 A minus 3/5 B plus B. And then you just have to work out minus 3/5 plus 1. That's effectively a 1B there, isn't it? So 3/5 A plus should be 2/5 B. Okay, that's the simplified answer. That is just literally your answer there. Okay, question 21. Let's see if we can see the whole of this, because we want to look at both graphs, obviously. We've got, here is the graph of y equals f of x. So all that means is just here's the original, basically. And I think it's just these three parts here. It's kind of diagonal across and diagonal down. On the grid below, draw the graph of y equals f of x, and then the thing that's different is now -4. So this is just graph transformations, and you just have to memorize what they mean. So because it's plus or minus a number, I know that that's a translation. First of all, that means it's going to go up and down, left or right. Then, more specifically, where is the -4? It's on the outside of the bracket, isn't it? Do you see how it's not with the x? So that means y-axis transformation. And hopefully you know that the y-axis is the right way round. What I mean by that is if it says -4, it means we're going down. Down by 4. So all this means is I need to take the original and just move everything down by 4. So have a look at each of the coordinates. If we start here, this was -3, 0, wasn't it? So it's still going to be at -3. It's going to then be -4. So it's going to be here, isn't it? And the next one was -2, 1. So 4 down would be -2, -3. Then you can see the next one is just 1 across, isn't it? And then you had 0, 0, which is now 0, -4. And then you just join that up. obviously use your ruler because it's a straight line, this one. If you can see all of that, hopefully, yeah, you can see that. Okay, that's my answer for part A. Literally just that. And I think on the next page there's another one, so we might have to flip back and forth a bit. Yes. Part B, on the grid below, draw the graph of y equals f of negative x. So when it's a negative and there's no numbers, that means it's a reflection. So it's either a reflection in the x or the y-axis, and then we have to figure out which one of those it is, based on where the negative is. So the negative is next to the x. I always think of this as the wrong way around. Because it's next to the x, it's a reflection in the y-axis. Now the reason why is because we're actually making all of the x coordinates negative, or just, you know, those are the ones that are changing. So that would reflect across, wouldn't it? Which is therefore a reflection in the y-axis. So if I probably go back, I might need to just copy this one just so we can see where it was originally. Obviously on yours, you'll be able to look at both pages at the same time, so that's fine. So here we've got the original coordinates. We're reflecting in the y-axis, so this vertical line here, imagine you're sticking a mirror there. The point 0, 0 is on the reflection line, so that would stay the same, wouldn't it? It wouldn't move because it's on the mirror line. The point negative 1, 1, it's still the same height, but it would now become positive, wouldn't it? So negative times negative is positive. The point that was here, negative 2, 1, would be positive 2, 1. And then the point that was negative 3, 0 would be positive 3, 0. See how that's literally just reflected if I try and... Let me pick this up, yeah. See if I drag this across, it's reflected horizontally, hasn't it? We've changed the x coordinates because we've reflected it in the y-axis. So however you want to memorize those transformations is up to you. There, more or less, something like that. Okay, that's part B. Okay, we're getting closer to the end now. I've got 3 more questions, okay. So, question 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. So, this, I tend to like to translate it, to be fair, into X. You don't always have to, but sometimes I like to translate it. So, blue pens is 4 times the number of red pens. So, red is like the smaller number, isn't it? Oh, where's my pen? So, let's say if red is X, always put the smaller one as X. Blue would therefore be 4x, wouldn't it? I just like to translate it like that, so it's not in words anymore. Rita takes at random 1 pen from the box. She records the colour of the pen and then replaces it in the box. Rita does this n times, where n is greater or equal to 2. So I'm thinking this is effectively a probability tree situation. Again, you've got different events. She takes a pen. The second event is she takes another pen, so on. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. This is quite hard, this one, but I have seen it actually asked before as well. Not the same context, but the same exact question. So I like to visualize it with a tree. You don't have to do this, but I just like to look at it. You're either going to get blue or red, aren't you? Now we need to know the probabilities of blue and red, which I think if you look back at the x and the 4x, that might help. In the box in total, therefore, would be 5x, wouldn't it? Do you see how, therefore, blue would be 4 out of 5 as a probability, and then red would be 1/5? That's kind of how I translate it. And then this, obviously, she's going to do it again. Now, the probabilities don't change because they did say she would put the pen back, so it's still 4 out of 5, and red would still be 1/5. And the same here. Blue 4/5, red 1/5. Now, the difficulty is we don't know how many times she does it. It's 2 or more, isn't it? So do you see how it could carry on? As many n times. We don't know how many columns there are going to be to this tree. So they've said write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. It's hard because you don't know how many times they're going to do it. Blue, red. I'm just doing this to demonstrate really at this point. Now, the way that we can do this is we obviously can't work out all the possibilities, because when it's at least once, it could be blue here, and then it could be red here, and then it could, it could be any kind of combination, couldn't it? We obviously can't account for all those combinations because we also don't know how many times we've got the columns. We don't know how many times she actually repeats this process. What we do know, though, is she has to have at least one blue pen and one red pen. She has to. So do you see how that would mean that I couldn't have all blues? If you followed that line, it would just keep going to all blue, wouldn't it? Do you see how it couldn't be that row? Because it has to have at least one red. And then in comparison, it can't be all reds, all of this line, if we follow that one, because she has to have one blue at least, doesn't she? So it could be any other combination in the middle. If you imagine that this carries on, it could be any combination in the middle, but it can't be all blues or all reds. So the easiest thing would be to do, obviously all probabilities add up to 1, right? Would be to do 1 minus the chance of getting all blue, and then minus the chance of getting all red, because then that would encompass all of the other possibilities. So we just need to work out, okay, how would I write down the probability of getting all blues? Again, I don't know how many times she repeats this. I know the probability of blue is 4/5, and when we're working with trees, we obviously saw this in the other question, you always multiply between them, don't you? So you're multiplying 4/5 by itself, again and again. How many times though? Well, it would be n times, wouldn't it? If you want all blue, it would be 4/5 to the power of n. And then the same for the red, but obviously red would be 1/5, wouldn't it? Imagine if you were getting all reds, it'd be 1/5 times 1/5 times 1/5, again and again and again, n times. So you don't have to draw this tree, but it's just to kind of demonstrate it for you why this makes sense. The probability of getting at least one red and at least one blue is 1 minus the probability of getting all blues or all reds. Hopefully that makes sense, but this is your answer here. Because we can't account for all these possibilities in the middle, like all the different combinations. Is it blue first? Is it red first? Is it blue second? Red second? Like we can't account for that because there's just too many. And we don't know how many times she's going to repeat this process. We don't know how many columns this tree is going to have. So we just have to account for the fact that we can work out all the blues, all the reds, and we don't want those. So we're going to subtract them from 1. Okay. Okay, 2 more questions. So question 23, here are 3 similar triangles, ABG, ACF, and ADE. So similar means that they would technically have all the same angles, but they're just a bigger scale. Like one's just been multiplied by a scalar to make the second one. So they've said that ABCD and AGFE are straight lines, which you can obviously kind of assume based on the information. And then they've given us a ratio. AB to BC to CD is 1 to 2 to 3. Show that the area of ABG, which is the triangle, to the area of BCFG, which is just this, what's that, like a trapezium, to the area of CDFE, another trapezium, is 1 to 8 to 27. So another tricky ratio one here. What I would do, I think, is I would try and create a ratio for the 3 triangles. But you see how all 3 triangles start at the point A? So my ratio would be like, obviously AB is still 1, isn't it? Then A to C would be 3, because you'd add those together, wouldn't you? Let me write this here. So AB as a side length is 1. AC as a side length would be 3, because it's 1 plus 2. And then AD as a whole of that side there would be 6. Now, when you're doing ratio and area and things like that, obviously we're not doing half base times height because we don't have enough information to do that, do we? So area, just think of it as 2D, isn't it? Squared. So therefore the area, the ratio for the areas would be 1 squared, which is 1. So this is area. 3 squared is 9 and 6 squared is 36. Because area is normally, well, it's always squared, isn't it? To the power of 2. So this was like the one-dimensional side length, isn't it? Sides. And then this is area, which is now 2-dimensional. However, this is the area of the triangles, right? So this triangle here, then this whole triangle here, then again this whole triangle here. Whereas the one they want, you see, was obviously the first one was the area of that first triangle, so it is still 1. But do you see how the second one, try and get my highlighter, is just this bit, which would be the whole of triangle ACF minus the first triangle. So all we need to do for the ratios then is subtract. So the triangle ABG, we already know, was the same as this first ratio here, 1, isn't it? That's fine. That's the same. But then the next one is not a triangle, it's that trapezium. So that trapezium is triangle ACF, which was 9, minus triangle ABG, which is 1. See how that's where they get the 8 from? You would do 9 minus 1. And then the same with the last bit, CDEF would be, let me get rid of this now. This bit here minus triangle ACF, which was 9. So 36 minus 9. And that's where you would get the 1 to 8 to 27 from. So if you've got a ratio and they're talking about side lengths and they've got area, you can just square the side lengths. You don't have to worry about the actual formula for whatever shape it is. Okay, I don't know if you can actually see that. Let me move that up. Hopefully you can see that there. Okay, this is our final question. So, question 24. The diagram shows 8 regular octagons joined to enclose a shaded shape. Each octagon has side lengths A. So like A, all of these are A because it's regular. Find in terms of A an expression for the area of the shaded shape. Give your answer in this format. So obviously we don't have a formula for this kind of star shape, do we? So I would try and break it down into shapes that are actually more recognizable. And I think the most obvious thing to do is just, if I draw a straight line here, we draw these 4 straight lines. See how it cuts off and creates this? That's obviously a triangle there, isn't it? On the outside. It's very fiddly. Obviously you can do this with your pencil and ruler. More or less, just imagine these are straight. Okay. We've got 4 identical triangles and then this is a square. If you want to know why it's a square, obviously I know it looks like it, but just we try not to assume these things, do we? I can work out the angles to show you that it's going to be a square. So the first thing is they've said regular octagons. Now I'm assuming you don't obviously have memorized the angles inside an octagon. If you do, I mean great, but you don't have to. The formula that we would need to work out an angle in the octagon would be n minus 2 times 180. That would tell you the total degrees of a whole octagon. And if you wanted to work out one angle, because obviously they're all the same, they're regular, divide by the number of sides again. So that would be, in this case, 8 is obviously the number of sides, minus 2 times 180 would tell us the total degrees. And if I divide that by 8, that would tell me how many degrees is one of the angles. I'll grab my calculator. 8 minus 2 times 180 over 8, 135 degrees. So that's the first thing I would work out. So you see how like each, that would be 135, that would be 135, that would be 135, that would be 135. All of them are 135 inside the octagons. That's 135. That's 135. Do you see how I could then work out whatever this bit here is, just in case you wanted to know that? 360, because it's a point, it's around a point, isn't it? Minus 135 times 2. take your answer, times it by 2. 360 minus that is 90 degrees. Okay? So you know, we're not assuming that it makes a square is 90 degrees. Based on that, we also therefore know if that's 135 and that's 135, do you see how this would be 90 as well, inside the triangle? And they're all the same, aren't they? That would be a 90 degree angle there as well. So we've got that information. What we could do then is we could work out the area of the square and work out the area of the triangles. Obviously, work out one triangle times it by 4. So let's do the triangles first. So area of a triangle normally is half base times height, but I think in this case, because I don't have the perpendicular height, you could work it out, but I think that's just going around the houses. What I would do is just use the trigonometric area of a triangle, you know, right up here, half AB sine C. It should be on your formula sheet. So the angle we know is 90, and then sides A and B are the other two sides, aren't they? So that would be half A times sine 90, which obviously in our calculator, sine 90, let's work that out, unless you already obviously have it memorized, is just 1. So that's effectively not there. So do you see how that would become a half? Obviously A times A is A squared times 1. That makes no difference. So that is one triangle. Now we do actually have 4 triangles, so I'm going to multiply that by 4 just right now. So 4 triangles. It's just basically a half times 4, isn't it? Which is 2A squared. So that's the area of the 4 triangles. Now I just want to know the area of the square in the middle. So I can see that this bit here would be A, this bit here would be A, but the problem is, get my highlighter, that I don't know this section here, do I? That's not another A, is it? I need to know that. And that is one side of the triangles that we have. So what I was going to do is use cosine rule, because I have the other 2 sides, which are A, and I have the angle opposite the one I want. So that would be 3 sides, 1 angle. Obviously one of the sides I want to know. So for the length would be, obviously use your cosine rule formula. The length squared is A squared is B squared plus C squared, isn't it? Which in this case is the A's. So A squared plus A squared minus 2BC, which again is 2 times A, cos of the angle, which is 90. Now, again, you might know what cos 90 is, but if not, you can obviously look it up. Cos 90 is 0. So if I were to multiply all of this by 0, it's just not there anymore, is it? So that bit, that subtract section is no longer there. Move this up again, so I think. So you can see. So all I'm left with is then A squared plus A squared, which is 2A squared. Now, remember though that that is the length squared. Okay, so you'd have to then square root it, wouldn't you? Root 2A squared is just that length. And then think of surds. You know with surds you can always separate them, can't you? So that'd be like root 2 root A squared. And you see how A squared, you can just square root it, can't you? Obviously root 2 you can't, but that would simplify to root 2 root A. Root 2A. Now that is, if we come back, this little bit in the middle here, isn't it? Root 2A. So the whole side length would be A plus root 2A plus A. I put whole length. A plus root 2A plus A, which would simplify to 2A plus root 2A, because you can't obviously add 2 and root 2. And then we know it's the same vertically, don't we? That's another A there, that's another A there, and then it's the exact same distance, because it's the same triangle, isn't it? So we know that's a square. So to work out the area of the square, obviously length times width, they're both the same, aren't they? 2A plus root 2A multiplied by itself is effectively double brackets, isn't it? So I would probably expand and simplify that now. So multiplying out, we get 4a squared plus 2 root 2a squared plus another 2 root 2a squared plus, and then the last one would be just 2a squared, wouldn't it? Because those root 2's would cancel. Simplify that, I can add the obviously the a squared, so that'll be 6a squared, and then I can add the 2 root 2a squared plus 4 root 2. Write that better than that. So that's simplified for the area of the square. That's quite hard because you have to remember kind of where we got to, and so we've got the area of the square and then the area of the 4 triangles. Those would add up to make the total area of the shaded bit, wouldn't it? Let's move this down just so I can have a bit of space. So hopefully you can see this here. Total area would be those two added together. So you've got 6a squared plus 4 root 2a squared plus the other 2a squared. These two can add together, aren't they? They're like terms. 8a squared plus 4 root 2a squared. So that's the total area. Okay, now the last bit is then to look at how they wanted us to format it. Do you see how they've actually factorised it? And what they've done is they've pulled out a common factor as a number. So p is just a number, isn't it? They pulled out the number at the front, and then they pulled out the a squared at the back of the brackets. Doesn't really matter. They've just separated them like that. So you could probably just do it in one straight go if you want, but otherwise we could look at it separately. So let's get some more space, shall we? If I just pull out the a squared, because obviously that was at the end, wasn't it? 4 root 2 a squared, and then just look at a common factor. Now it's obviously root 2 is separate because it's not a whole number. Just look at the 4 and the 8. Common factor, the highest common factor is 4, so then you'd end up with 2 plus root 2. And that, if we have a look at the original, you can see that is the same, isn't it? Same format. With, they said p is an integer, that's obviously R4, isn't it? Here and here. So there's your final answer for that one. Yeah, that one's quite a complicated one to know what to do with. There's always kind of a wildcard question, I feel like, that's one's... It kind of makes sense when you see people go through it, but you're like, how did you even think of doing that initially? Yeah, it's kind of hard that, I guess. So yeah, that is everything. As you can see, that was 5 marks, 80 marks on the total of the paper. That is everything for the June 2023 paper 2H, the second one. Calculator. If you want to go through any of the topics that we looked at in this paper, I have listed down as many videos as I've made in the description of this live or in this video if you're watching it later. So feel free to go through those videos if you want more examples of each of the topics. Otherwise, if you have any questions, please leave them down below in the comments and I'll try to get back to you as quickly as possible.